Hello and welcome to another coding session. How about that? So today is Friday, and today we continue to develop our programming language called Bang. You can find the source code of the language in the description. And in the previous episode, the link to which you can also find in the description, we introduced a very important thing to the language. We introduced the stack for local variables and stack frames in which we're going to store the local variables. Each stack frame basically corresponds to a scope, right? And we also implemented so you can compile the local variables. But a couple of things that I didn't have time to implement in the previous episode is an ability to read and write to and from and to, I didn't know the order, the local variables, right? So you can only compile them. Entering a scope pushes the frame, but all of that is kind of useless unless you can read and write local variables. And we even have separate issues for that, as far as I can tell. So I don't really remember. I think I'm going to filter by Bang. There's not warning about shadowing, assigning to a stack. Yeah, assigning to a stack variable. So this is the first one. Taking a pointer. Well, it also needs to be implemented, but it's not as important right now as being able to read from the stack variables. So today we're going to focus on these two issues: assigning to a stack variable and reading from a stack variable. So let's get started, I suppose. Let's get started. So I'm going to actually restart Emacs from within the development environment. And I'm going to go to the source code, and let's take a look at a couple of examples. So this is going to be Bang. I'm going to use a new mode for the highlighting. So here is an entry point. Right. I think I can do something like this. Hello world. I think you have to also put this kind of thing in here, and then you can try to compile this entire thing with. Oh, by the way, Bang can just run the example without like intermediate step of compiling and then running it. So you can just do compile and run with a single command, which is super convenient, as you can see. So it's, yeah, it works. Hello. Test something else, and as you can see, it is changing. So right now you should be able to create a local variable, right? You can create a local variable. It works perfectly fine. I wonder what's going to happen if you duplicate it. Yeah, variable x is already defined. The first definition was in here. Okay, so but you can't write into the local variable, right? So if I try to assign something, yeah, it fails with an assertion that refers to the specific issue that is related to assigning to a stack variable. So I don't know. Let's just go ahead and implement this thing. I think it's gonna be pretty straightforward. 4, 5, 6. Was it 4, 5, 6? I think it was 4, 5, 6. Assigning to a local variable. There we go. So, and how are we going to be assigning to a local variable? So in here, when we try to compile the variable assignment, we first query the variable in the current scope, and then we check this the variable storage, right? So right now the variables can be stored either in a static memory, like global variables and so on and so forth, and on the stack. And depending on the storage, the address of the variable has to be interpreted differently. So if the variable is stored in a static memory, the address of the variable is absolute. If it's stored on the stack, it is relative to the frame stack. All right, so the first thing we do when we try to access the static variable, we push its address on the stack, and then we compile the expression that we're assigning to the variable, and then we check the type of the expression and make sure that that expression is the same type as the variable, and then we perform the write. So that should be fine. That should be fine. So in here, we need to first get the address of the variable. So where's my nice sound, by the way. I want to reach my tablet. All right, so let's start my paint and let's take a look at how the stack currently looks like. So the stack is kind of similar to how x86 works with the stack, right? It starts at a particular place right here, right? So this is where it starts. And it grows towards the 0. And the reason why I do it like that is because I want the stack overflow actually go below 0 and trigger the illegal memory access in our virtual machine. So that way, if something overflows, instead of corrupting the entire, the entire memory, it will just, just fail, which is precisely what I want. Okay, so we have stack frames somewhere. So you have some data here, which doesn't matter. And this is where stack frame starts, right? So the stack frame starts somewhere here. So it's quite important that part of the stack frame is also a variable that points to the previous stack frame. So it's sort of like a linked list of stack frames. So this is where the frame starts. Right, so first thing we need to do, we actually need to read frame, right? We need to read frame. And I think we already have a function to do that. Compile read frame address, precisely. Yeah, there we go. So you can just read the frame address, and there you go. You have a frame address on your operand stack. So we have two kind of stacks. We have a stack for local variables that is located in the memory, and we have a stack for operands, which is located in its own separate memory. So after that, what I need to do, I need to take the offset of the variable, and I think that offset is stored within the variable itself. If I compile the variables, yeah, here's the offset. So depending on the storage, this variable just means two different things. In case of a static storage, it's an absolute address. In case of the stack storage, it's an offset starting from a frame. So that means the next thing we need to do Basm push instruction. The instruction that we're pushing into the Basm is going to be instruction push, because we need to push an offset, right? So we're pushing an instruction that pushes the operand on the operand stack, right? So a lot of meta levels. And what's going to be the offset? Word U64. I think it has to be var. Is it called var? Yeah, it is called var, and it's going to be address. There we go. So now we have two operands on our stack. The first one is the frame address that comes from this thing, and then the variable address. So the next thing we need to do, we actually need to subtract the variable address from the frame address to find where the variable starts, right? So that means I'll have to push yet another instruction. It's going to be Basm push instruction Basm minus I, and this operation doesn't get any operands, so we're going to leave it as it is right now. So after that, as far as I know, the result is going to be something like this, and here we go. We have an address on the stack for the variable, right? So after that, we need to repeat this kind of stuff, right? So we need to compile the expression. We need to compile the entire expression, and then compile the write. So this is where reading, assigning static variables and stack variables is pretty much the same. And what I'm thinking is that maybe we can basically extract all of that into like outside of the switch case. So in a switch case, we're basically compiling the access to the variable, and then we're just compiling the rest of the expressions. So let me just grab this entire stuff and put it after the switch case, right? So now it's after the switch case. And in case of a static, we just push this thing onto the stack. And in case of a stack, we're reading the stack frame, then we're pushing the offset, and we're subtracting the offset from the stack frame. And there we go. We have an address. We have an absolute address of the variable. We have an absolute address of the variable. Cool. Let me see if this entire stuff compiles. I hope I didn't miss anything. So let me rebuild this stuff and see how it goes. Okay, it doesn't compile because this thing is implicit declaration. This is because it probably has to be defined a little bit higher. So let me move some of this stuff above here. Maybe at some point I'm gonna actually make it like public relative to the current translation unit, but right now I don't really see any point in doing that. Okay, so that looks good. That looks good. So let's come up with a simple example. I think we already have a simple example. This thing is basically a simple example. It's as simple as you can get it. So let's just compile this example and then disassemble and see what's going on in there. So bang build. I also want to set this stack to something smaller than 4 kilobytes because it's going to be reflected in the debasm. And I'm going to just build full bang. There we go. So we've got the full bang. And after that, I think I'm going to go to debasm and simply disassemble the entire thing. There we go. We managed to disassemble this entire thing. So here is the stack. And here is how we try to access this stack. So some of the code, I think 13 instructions, 13 instructions here are related to pushing the new frame into the stack, and then we have, yes, then we're pushing this kind of thing, and then we're popping out the frame out of the stack. All right, looks good to me. Looks good to me so far. So I'm a little bit scared to run this entire thing. I don't know why I said this stuff. So first, instead of running, I'm going to actually enable tracing. Right, and tracing essentially shows the memory footprint on each individual step, but I think you cannot see anything because we're showing a very small window. So let's actually make the stack a little bit smaller. Okay, so that's pretty cool. So this is where we store the current frame. It is 20. As we go further and further in instructions, right? Yeah, we pushed another frame in here. Right, so we stored the previous frame, and then the current frame became 80. All right, so at some point we're probably gonna, okay, so we have additional value 45 in here, right? Additional value 45, and if I understand correctly, 45 is 69 in decimal. Okay, so after that we're returning correctly, so nothing is corrupted so far. So the entire memory stack looks fine. Which is pretty good, which is pretty good in my opinion. Okay. So, but it's kind of, I don't even know how we can test this entire thing. I want to be able to just look at the value of the variable, but I can't read it anyway. So it's kind of pointless to test this entire thing unless you can read from this variable. So I guess I'm gonna just commit this entire thing without testing, right? So, and move on to reading from the variable. And once we have both reading and writing, this is where we can properly test it. And the way we're gonna test it, I think I'm gonna go to one of our examples, like rule 110, and basically finally introduce the local variables, because this entire thing was written without any local variables, and that was painful, right? So we had to make things like I and J global ones, and also these things should be local ones, and yeah, at least we will be able to move these things inside of their scopes. This kind of stuff has to be global, right? But these things are pretty much local ones. So once we have the local variables, we will be able to make it a little bit easier for us, hopefully. We'll see. All right, so let me quickly commit this entire thing and make a pull request. 456 implement variable assignment. Okay, and I'm gonna push that right into the repo. So let's create a pull request. So it's going to be close 456, right? And while we're waiting for the continuous integration, I think I'm going to make a small break and make a cup of tea. And after a small break, we're going to continue, working on this thing and implement variable reading. So everything seems to be passing, and let's merge this entire stuff and move on to reading stack variables. So yeah, let me actually go to the master and fetch the latest stuff. Merge origin master. We'll have to move this entire thing. Let's have an example with variable reading. So the easiest example I think would be to do something like this. So we're going to have 34, and then we're going to do x equal to x plus 35. Right, there we go. So that will require to read the variable and reassign it back to it. So this kind of stuff is not going to compile because it's going to hit the assertion. There we go. So as you can see, reading stack variables is not implemented. So this is precisely what we want to have in here. Compile typed read. This one is interesting. Okay, I'm just realizing that here, to read the variable, we also need to get the address of the variable. And it's very similar to how we do that for assigning the variables. Right, so where is assign? Compile bang assign. So yeah, so for the static one, you just push the instruction. For the stack one, you calculate it relative to the frame. So maybe this entire thing could be actually extracted to a separate function as well. Something like compile get variable address, if you know what I mean. Compile get variable address, which can be then easily reused for taking the pointer to the variable, right? So taking pointer to the variable is not implemented. Yeah, so it's going to be like a simple function that you can reuse for all of the three situations, like reading from the variable, writing to the variable, and taking the pointer to the variable. So yeah, okay, that's actually pretty cool. Let me see how I can call this entire thing. So compile get var address. Yeah, this one is very interesting. So we're going to accept bang and we're going to accept the Basm into which we're compiling everything. And I suppose we're going to be accepting compiled variable. I think it makes sense to accept the compiled variable because that's what's needed in here. Like just basically depending on the storage, we just take the absolute address or relative one. So, and I can just move the entire thing in here to here. So this one could be just static. I don't think it needs to be visible like outside. And I think that is it. And essentially what I can do, compile get variable address, right? Compile get variable address, bang Basm the variable, then we compile the expression, and then we check that the expression has the same type as the variable, and then we compile typed right. Perfect. I think that's actually pretty cool. Yeah. Compile bang variable read variable assign. So what's the issue number? 454. 454. So compile var read. Okay. So and in here essentially I want to do a similar thing. Compile get variable address bang Basm var. So this is where we got the variable address. And believe it or not, I think that is it. So then I can just do compile typed read. So yeah, that's it. Actually, that is actually it, because we already have everything implemented in here. So get variable address, depending on the storage of the variable, is going to be either on the stack or on the static memory, and then we just read this entire variable. Pretty straightforward. All right, that's pretty cool. Let's rebuild the entire compiler. Okay, so this thing is not visible there, so let's maybe move it a little bit up there. I should probably add it to the headers. I think that would be a good idea, but I'm too lazy to go to the headers right now for some reason. I don't know why. It do be like that sometimes for me. Well, I mean, I think the time has come. Let's actually move all of these things to a header. Right, so let me find all of the places where I have this kind of stuff, static binary OP of type. Yeah, so this thing needs to be moved somewhere here. So this is now that. Compile get variable address, another static reinterpret expression as type. Maybe this one is not really important. Compile, yeah, so this one is another one that needs to be put in here. It's not static anymore, and this is the second one. Yeah, this is not static anymore. Do we have anything else static? Push new frames, pop new frame. Let's actually move this entire stuff here. Why not? And this is going to be something like this. So it's also going to be like that. All right, so we're not going to have this implicit declaration situation anymore, hopefully. And yeah, it seems to be working. So now if I try to run the entire thing, it actually successfully ran. At least it didn't crash or anything. On the stack, we don't really see much in here. Okay, that's pretty cool. So I think it actually works, but it's kind of like difficult to see. Like I can see that in the memory, but visually from the behavior of the program, it's not really that visible. So I have an idea. It would be kind of cool if, you know, in the example, we could do something like write ptr, and I could just take a pointer to this variable and say print one character. So that will turn into a single character. And if you take a look at the ASCII of 69, right, so where's 69? It has to be E. So that thing should just print a single E. But again, we won't be able to see that because we cannot take the pointers to the variables, right? So as you can see, it's a separate issue. It's kind of cool that here we have all of the three features working together. Actually four, right? So you can compile the variable on the stack, you can assign to the variable, you can read and reassign again, you can take a pointer, and this example basically demonstrates all of that. So it's actually pretty cool. You can demonstrate all of that in four lines, a line per feature essentially. So okay, let's actually make another pull request with implemented variable reading, and also implement taking a pointer, and just see how these features work together. All right, and they should work together. If they work together, that example will print a single E. All right. So it's a 454, right? 454. And let's go ahead and say that we implemented variable reading. Implement local variable reading, and I'm going to push that right into the repo. And of course, we're going to create the pull request for this thing. So it's going to close 454. There we go. And let's wait until the continuous integration is done. All right, it is done. Let's merge it. And let's fetch the other stuff. And move on to implementing taking a pointer to the stack variable. And I think this one should be pretty straightforward. 455. So let me go back to our example, foo bang, and let's just go ahead and compile it one more time, and this is where it happens. So essentially, we already have everything to implement that. What we need to do, we just need to take a pointer. Yeah, we just need to take a pointer to the variable. So we just need to compile the address. Compile get variable address. I provide the bank, I provide the Basm, I provide the variable, and all of that stuff is not needed, except variable type has to be actually moved somewhere here. And there we go. This is the entire implementation. That's it. Right, so you get the compiled variable, you get its address, and then you just say, okay, the type of this address is a pointer, and the compiler will compile everything as it should. So yeah, that's pretty much it. So now pointer doesn't really care about the storage of the variable. Right, so depending on the storage, it will just take the address of the variable from different place. Right, so where is the compile get variable address? So this is where we have switch case, right? Depending on the storage, right? If it's static, we just do that. If it's stack, we just do that. Pretty straightforward. All right, and if I try to recompile the whole compiler, let's see what's gonna happen. And let's just run this entire thing, and look at that. It printed E. It works, right? That's actually super cool. I really like that. So we allocated a variable on the stack. We assigned 34 to that variable. Then we read it again. We read 34, added 35, and save it back. Then we took a pointer to the variable, treated the variable as ASCII symbol, and printed one character in there. To be fair, if the endianness of the stuff was a little bit different, we would see 0, right? Because the size of the variable is 8 bytes. So I think technically it has to be like U8, right? But it's not going to be like syntactically pretty, if you know what I mean, right? Because now I'll have to cast this entire thing to U8 because our language is not particularly convenient. Cast U8, and it still works anyway. So let me actually disable the trace so it doesn't. Yeah, so here's E. On top of that, we can maybe repeat that several times. And now, by the way, repeating things is super easy because I can just allocate a counter in here on the local stack. And then while I is less than 10, I'm going to be doing that. And then I'm going to be reassigning I plus I. And there we go. So that's pretty cool. That is very, very cool. Illegal, nice! And you know why? I think this is because the stack is very small, right? We allocated 32 bytes on the stack. And to be fair, you need to store a lot of shit on the stack, right? You need to store the variable. Then you also need to store the pointers to the previous frames and stuff like that. Yeah, so you need a lot of shit on the stack. So this kind of example may not work with such a small stack, but well, we have a bigger problem right now. I don't know how to stop this entire stuff. Well, but I managed to do that. Okay, so everything is absolutely broken. All right, that is very, very interesting. Cool. We corrupted the stack. Yay! We corrupted the stack. I'm super happy. I thought today is going to be a very quick episode, but yeah, you know you're going to have a lot of fun if you corrupted the stack. So, and since the variable I is located on the stack, right, it probably corrupted I itself, so the loop may never actually finish. So what if I move this entire thing? Yeah, there we go. Something is definitely corrupted in here. Maybe this is because of U8, right? If I move back to I64, right, so we're moving back to I64, it still doesn't work, which is kind of interesting, right? But it works with a single one, right? So if I do it like that, it prints E. But if I try to do this kind of stuff, oh, okay, this one is rather interesting. Oh shit! Oh shit! Oh fuck! I know what's going on. I fucking know what's going on. This is actually super interesting because we have a scope system, right? So we have a scope here, so the variable x is located here, and then we have a separate scope where we do the while, right? So, and essentially while pushes its own frame on the stack. So essentially when I try to access x from the closest scope, I try to use its I essentially try to use its frame, but I should use the frame above. Right, I have to use the frame above. This one is very interesting. Okay, so luckily I actually caught that without like going deep into the debugger, so I caught the logical error. All right, so how can we do that? So I suppose it just depends on the scope of the variable. So maybe the scope of the variable has to be attached to the compiled variable itself. All right, so let's go back to the compile.c. Yeah. So compiled read address. Yeah, what it does, it just takes the current scope, right? It just takes the current scope. No, there's nothing particularly interesting in there. Wait. Yeah, read frame address. Read frame address and bank stack frame address. So it takes the current thing. And this one is even more complicated than I thought. Ooh, this one is very interesting because we have no way to get the corresponding frame. We literally have no way to get the corresponding frame. But maybe there should be a way to get the corresponding frame, because it's kind of like an information that we know at compile time, if you know what I mean. All right, so I need to think about this one a little bit more. So let's make a small break, and after the break, we'll see what we can do about that. All right, I think the solution is going to be simply to not push the frame on each individual scope. So we only need to push the frame on at the beginning of the function and pop the frame at the end of the function. So inside of the scope, right, what we're going to be doing is, if we encounter a variable, we're sort of allocating the variable inside of the frame, and when we basically go out of the scope, we deallocate the variable from the frame. So we need to introduce the separate notion of the frame. Let me see how we can do that. And scopes themselves are going to be referring to the frames rather than, yeah, so they already store frame top offset, but this is because scope is the frame, right? But we need to separate the notion of the scope from the notion of the frame. So the way we can do that, I think, is by literally introducing something like bank frame. Right, and it's going to be, let me put it like that. We'll put it in here, and we're gonna have a memory address. So let's actually call it top offset. Maybe just, yeah, just an offset. There we go. So this is gonna be something like that, and the scope itself is going to be referring to the frame, right? So you have a scope, and the scope is inside of a particular frame. So that makes sense to me, I guess. So, and what's interesting is that you can have a global scope that doesn't have any frame, and we can actually detect that, yeah. So essentially, if you are inside of a scope that doesn't have any frame, you won't be able to allocate stack variables in there. So we can put some assertions in there, which will prevent future bugs and stuff like that. This is actually pretty good. And that means that implicitly we have two kinds of scopes: the scopes that are inside of the frame and the scopes that are not inside of the frame. Global scope is not inside of any frame, so it means you can't allocate local variables in there. So yeah, it's rather interesting. Okay, so I think this is the right direction. So you know, so there's less, how to say that, inconsistencies with this direction. You really want to separate the notion of the scope from the notion of a frame. Oh, and by the way, frame effectively becomes the storage. So maybe the storage should be called not stack but frame. Right, but I mean, it's stack is also fine, right? So also here, maybe this one has to be called global. but sometimes you may want to have maybe not global variables, but they're static, like in C++, right? Static int x, it's not global, but it's, you know, static, it's in a static region. So I think static and stack is actually quite good. Okay, so I made the changes that I wanted to make, right? I wanted to introduce the notion of a frame, and I think I'm gonna just follow compiler assisted refactoring, follow compilation errors, and see if we can fix them. So this entire thing is going to give us the refactoring. All right, so stack var definition into Basm. So you're trying to compile this thing like so. So frame top offset. So what that means, that means instead of this thing, I take the scope, I have to take the frame and add the offset. So many levels of indirection, my god. Yeah. And I think if you're compiling a local variable, a stack variable, right, you're compiling a stack variable, you should have a frame. So we're gonna assert that you do have a frame in here. If you don't have a frame in here, that means you're using this function incorrectly, right? So there we go. But maybe we can make it a little bit more interesting. Like if you're compiling the variable inside of the scope that has a frame, it's going to be allocated on a frame. But if it doesn't have a frame, you put it into the static memory. I think this is kind of stuff that the user has to decide explicitly, so I'm not going to do that. All right, so let's go ahead and do that. So, and then I assign the address of the this entire thing. There we go. So this is the two assumptions that we make in this particular code. The next one, compile push new frame. Okay, this one is quite important. Frame top offset. So that means the frame, if you push in the new frame, you have to actually know the offset of the previous one. Right, you need to know the offset of the previous one. This one is rather interesting. So, otherwise you won't be able to do that. So it's just a compilation of the new frame. So if it's a compilation of the new frame, maybe we shouldn't depend on a bang per se. So compile, right. Do we need to know this kind of stuff? So if you compile frame read, do we even use anything in here? Bang stack variable address, stack frame variable address. It is needed in here. So maybe it's not what I think it is. So let me go back in here. Compile push new frame. I need to know where this thing is called, right? So this thing is called somewhere here. There we go. If you push a new scope, okay, so here is the interesting stuff. I think when you push in a new scope, it does not necessarily mean that it creates the frame. So that means the frame has to be customizable. Bang frame, there we go. So, and this thing doesn't matter anymore. This entire stuff doesn't matter. You create the scope, you allocate the scope, then you set the parent scope, then inside of the scope itself, you set the frame that was given in here. So I want to have a control over, like, you know, what kind of frame is used for the scope. And when we pop the scope, it does not necessarily mean that we need to pop the frame, but it does mean that we need to deallocate all of the local variables. This one is rather interesting. Yeah. So if you pop the scope, you need to iterate through all of the variables of the scope, right? And find the ones that are allocated on the stack and basically deallocate them from the current frame. So if bang scope has a frame, right? It has a frame. We are starting to iterate through all of its local variables. So I bang scope, and I don't quite remember, so it's going to be compiler.h. So it has a vars count. Vars count. You know what? I think I can do something like this. It's going to be bang scope, scope, bang scope. There we go. So that way I don't have to like constantly dereference this entire stuff. So here is the current scope. Then I go through the scope variables count, and it's going to be plus I. There we go. And if the scope vars I storage is equal to bang var stack storage, right? So this is a stack storage. I need to take the size of the variable and essentially store it somewhere, because basically the amount of set that we have to make from the frame is the concatenation of all of the variables we allocated inside of the scope. Right, so size, dalloc size initially is going to be 0. Right, and how can I get the size of the variable? So compiled var probably does not store its own size, right? So here it is. So it knows its address, but we do have a type of this thing, right? So that means I can do scope vars I, and I can take the type of this variable. So then bang get type definition. I don't remember where can I get the type definition. Okay, so that means I can do something like this, right? So there we go. I got the type definition. Bang type definition. Here is the definition, and inside of the type definition we do have the size of this variable. So that means I can do something like definition size. Add to deallocation size. There we go. So we iterated through all of the stack variables and we concatenated all of their sizes, and that's precisely the size that we need to subtract from the frames of set. Right, so there we go. So then the next scope can allocate something there as well. Right, so I guess that makes sense. All of that does in fact make sense. And when you are allocating variable on the frame, you're increasing that offset. Yeah, so, and the allocation is decreasing it. All right, looks good to me. Looks pretty good to me. All right, so maybe I also... Okay, so let's just go to the compilation errors and see how it goes. Okay, compile new frame top offset. Okay, so when I push the new frame, I'm just thinking, where should I get this offset from? Where do I get this offset from? So I guess I get this offset from... maybe I need to customize it there. So you push a new frame, and that offset is stored in the current frame. Yeah, that offset is stored in the current frame. And the current frame, what if the scope doesn't have a current frame? So let's actually modify this entire thing to accept the frame top offset. Like so, it's going to be UN64T, maybe, yeah, memory address. I'm still not sure about that one, frame top offset. So it's going to be frame top offset, and there we go. Okay, so let's go through the rest of the compilation errors. So what does it say? Conflicting types with the header. Okay, let's update the header then. Push new frame. There we go. And I'm going to remove this stuff. And that offset is going to be taken from the current scope, right? From the current scope. Alrighty. Okay. Push new scope, another conflicting situation of our nation. Push new scope. There we go. Emacs is difficult to use. I should switch to V. Oh, I'm sorry. So we're compiling the block, and when you're just compiling the block, I guess you want to just simply inherit. Oh yeah, this one is rather interesting. You quite often you want to inherit the frame, but so if the block is the body of the function, I want to be able to push a new frame. If the block is while or if or something like that, I don't want to push the frame. So maybe because of that, I also need to customize the frame here as well, right? So the frame is going to be it has to be a pointer, right? It is definitely has to be a pointer. All right, so, and because of that, the frame is going to be put in here. So we push a new scope with the specific frame, then we compile each individual statement, and then we pop the scope, and the scope will actually, by the way, deallocate all the things. Okay, so that's pretty cool. And let me recompile this entire thing and see what's going to happen. Okay, compile block also conflicting in here. Compile block into Basm. And I'm going to remove this entire thing. So what we're going to have in here. Compile block into Basm. All right, this one is cool. This one is pretty cool. So the frame that we have to use, in here is the frame from the current scope. All right, so bang scope frame. So that's essentially the frame that we want to use. But that means that we expect the scope to exist. And that makes sense, right? If may not exist in like outside of the scopes whatsoever. Right, I think that makes sense to me. And yet again in here, we're also going to use the same frame, right? So we're just inheriting the frames. All right, so what's going to be the next thing? Block while. It's the same situation. It's just a bang scope frame, right? It's a bang scope frame. And another thing. Definition. Okay, now we're getting into an interesting part. So we're compiling the procedure, and procedure, the body of procedure should push a new frame. It must push a new frame. So and that means this is where it's gonna get very interesting. So compile push new frame. So before compiling the body of the function, we need to push a new frame, and after the body of the function, we need to pop that frame, right? We need to pop that specific frame. But before we can actually like supply some sort of a frame in here, we also need to allocate that frame somewhere, right? So it has to be something like bang frame frame, and we're going to be using arena. Arena alloc, bang arena. I think that's how we can use that stuff. And we're going to allocate specifically the size for the frame. The size for the frame. So the actual offset within the top frame, I suppose, is the previous frame. Right, it is the previous frame, and you can take the previous frame from let's say the current stack, right? So it has to be something like bang scope frame offset, and that's the offset we have to use in here, right? So that's the offset we're using in here. But what if the scope is global? The global scope doesn't have a frame, so maybe this the way we have to do that, right? So in case of the global scope, essentially we have offset equal to 0. So if this thing does not exist, right? If this thing does not exist, we just return 0. So that's how we're gonna approach that. Right, there we go. So we compile push new frame, right? We compile push new frame. Then the offset that is used for that new frame is this one. Then we are essentially creating a new frame. So we're creating a new frame in here, and then we need to pop the frame out, right? We're popping the frame out, and that's essentially how we're going to be doing that, hopefully. So a new scopes that are pushed in there, they're going to be using the new frame. Otherwise, they won't be using the new frames. Okay, so is it going to compile now? Let's see. Let's see. Frame. It's yet another, you know, indirection. Yet another indirection and new use parameter Basm. Okay, so when you push the new scope. Oh yeah, that one is interesting. So when you push the new scope, we don't need that. Do you use Basm in here as well? You don't. Okay, so we never actually do anything with Basm in here. Okay, so we can just remove this kind of stuff in here. Okay, thank you, compiler. Very cool. And that means I need to go to the header. Bang, push new scope, and there is no Basm in here. All right. So, and yeah, we have to go through all of the places where we do all of that. Anything else? Frame offset. So this is the indirection level that I was talking about. So, and in the pop scope, we also don't have the Basm because we're not, you know, compiling. We're not trying to push a new frame on each individual scope. Scope is just like, you know, maintenance thing for the compiler state. So nothing particularly special. All right, so pop the scope. That means I need to go to the compiler, pop scope, and this is going to be something like this. Okay. Okay. So what we're doing in here, run sub command. So you want to push a new scope, right? You're pushing a new scope, and yeah, in a global scope, you're not going to be. Well, this one, if this is a global scope, that means it doesn't have a frame, so I can just put null in there. Okay, that makes sense. Anything else? So this is yet another subcommand. So we have, yeah, so this is a build subcommand. The previous one was a run subcommand. There's a little bit of duplication code between a run and build, but I don't think it's that big of a deal. I don't think it's that big of a deal. All right, so it seems to be working more or less. So when I'm compiling the new variables, so compile var definition. Compile var def, right? So stack var def. Okay, so in case of a stack var def, what are we doing? We're updating the new frame and so on and so forth. So that makes sense. That makes sense, I think. Alrighty. So I'm still worried about this thing, if I'm doing this thing correctly. Compile, push a new frame. So it has to be specifically the offset of the previous frame, otherwise we won't be able to do that. But I think if you don't have any frame, you can just use the offset 0, so I don't think it's that big of a deal. All right, and all of that seems to be compiling and seems to be working, so I don't even know. Let's see, let's take a look at the example that we have in here. Okay, so let's try to start from scratch. We're starting from scratch, and let's just write hello world and see if the hello world, maybe even empty application. Okay, empty application. Will empty application exit with a successful exit code? At least that. So bing bang run foo bang. Whew. All right, so can we trace this entire thing? Okay, so here are the instructions that were executed, and yeah, I can push That is very interesting. Like, why are we pushing? Oh yeah, this is because it's the address of the after this stack, right? It's an address of the variable that stores the current frame. So everything seems to be okay. All right. So how about write hello world? Right. So how about write hello world? Let's try to run this entire thing without any tracing. Hello world is fine. I'm super happy about that. Okay, so what about now a local variable? I'm allocating a local variable. I don't even try to touch that variable whatsoever. Okay, it seems to be compiling, so let's actually introduce an error. And as you can see, there's no such type. It's just, it compiles way too fast, right? So essentially, here it compiles everything down to bytecode and then evaluates the bytecode, and it takes how much time? It takes like 2 milliseconds to do that. So yeah, so that's how fast it is, right? So it compiles everything down to the bytecode, it starts up the virtual machine and executes the code in the virtual machine, and it's just like within 2 milliseconds. Computers are fast. Surprisingly, who would have thought that if you don't overbloat your software, it's super fucking fast. Anyways, so what about writing to the variable? What about writing to the variable? So let's write 34, and seems to be working. I'm super happy about that. What about reading from the variable? What about reading from the variable? Seems to be working. That's really sus, but okay. What about taking the pointer? So let's actually write the pointer. And taking the pointer to the x, and basically treat it as the string with a single character. It printed E, as you can see. It printed E, so precisely what you expect, because the ASCII code of E is 69. Perfect. All right, what about allocating more variables on the stack? How about that? Let's allocate more variables on the stack. Is it going to be... it is working. What about assigning the stuff to this variable? It is working. So now I want to actually wrap this entire thing into a while loop that iterates 10 times, and on top of that I'm going to be actually constantly reading and reassigning I. Will that thing print E 10 times? God fucking cooter, would you look at that? It printed E 10 times using only local variables. How about that? How about fucking that, mate? That's super cool. All right, so that's nice. I don't have to use global variables anymore. So, all right, let's do a committee. So, actually, I have two changes in here. The first change simply adds support for the pointers for the stack variables. So let's actually commit that separately. And the other one introduces the frame. Okay, implement taken pointer to the stack var. There we go. So this is going to be the first thing. And introducing the frame is going to be the second thing. So separate stack frames from the scopes. Don't push a new frame on each and individual scope. Several scopes may share the same frame if they are the same frame. Only procedures, only procs introduce new frames into the scope, right? Other constructions, do I spell constructions, like while, if, etc., inherit the frame of the parent scope. All right, let me actually read it back. Don't push a new frame on each individual scope. Several scopes may share the same frame. Only procs introduce the new frames, right? The new frames. Introduce new frames into the scope. Other constructions like while, if, etc. inherit the frame of the parent scope. I think this is a pretty good explanation. All right, so, and let me push that right into the repo. So, and another thing, since we have proper local variables and stuff like that, maybe we can go back into our example, like rule 110, and finally get rid of those ugly intermediate variables, if you know what I mean. So in rule 110, right, we introduced these variables, which are basically like temporary auxiliary variables that could have been just local variables if the language supported local variables. It didn't support at the time we wrote this code, but it supports them now. So let's actually go ahead and basically comment it out and go through the process of compiler-assisted refactoring. Yes, our language supports compiler-assisted refactoring just because it's statically typed. All right, and simply keep rebuilding this entire thing. So I'm gonna try to build rule 110. Rule 110, and I'm an idiot, so let's go back in here. This one has to be something like examples, and there we go. So as you can see, you're trying to assign a variable that doesn't exist. Let's actually make it a local variable. Why not? It is a local variable now. Okay, this one is a variable that is not really visible outside of this entire thing, so maybe we can do something like var cell ptr. Is going to be ptr, and then var cell u8. But here is an interesting thing. So it is used here somewhere. So let's actually see how it's going to work. So yeah. So it kind of used outside of the while loop. So maybe it makes sense to allocate them like on top in here. Yeah. The only reason why we need these variables is because the working with pointers is not particularly convenient. But if we make working with pointers more convenient, we can actually make this code a little bit shorter. Of course. So what do we have in here? Yet another situation where we can allocate something like this. I64 var cell ptr, and this one is cell u8. What else do we have in here? And in here, yeah, the only reason why we have j in here is because the variable I is used by these procedures, right? Because I and j are global. But now, since all of them are local, I can just do something like this. I can reuse the I. So there's no need to introduce j anywhere in here, right? So there's literally no reason to do that. So we can just use I. Because it's a local variable. And let's see if it compiles or not. And it seems to be compiling, but we never actually run it. And I'm actually super scared to run it because I'm not sure what's going to happen. Right, because the code is relatively complicated. So is it going to be first try got cooler moment, or is it going to be yet another failure where I'm going to go home and cry? So we're about to find out. We're about to find out by just switching the build command to run command, and well, I mean, I'm running it from a wrong folder. It doesn't count, right? One more time, and it is in fact a failure. So. Fuck. All right, that's very interesting. I wonder what the fuck has happened. How did that fucking happen, mate? How did that happen? It only printed like the first line or something. I don't know. So okay, if I actually remove the loop, right, so we just print the state. Okay, so there's something wrong with printing the state, right, because as you can see, it doesn't change. If I comment out printing the state, it is fine, but if you try to print the state, something is horribly wrong. So what's wrong with printing the state? I don't quite get it. I'm sorry. Don't quite get it. If I quickly switch this stuff to a global scope, is it gonna work? No, it doesn't really work at all. It still doesn't work. Did I fuck it up? Did I really fuck it up? I don't think so. I don't think I fucked it up this badly. So if I stash the changes, right? So if I stash the changes and try to run, it is working. So it is probably not with like the local variables as the feature of the compiler. Well, I mean, okay, it's kind of difficult to explain what I mean. Anyway, so let me see. So at least we know that we have some sort of problems in here. All right. So I'm gonna comment out this entire stuff, and then I'm trying to print the state current. Right, I'm printing the state current, and oh wait, I'm an idiot. I forgot that rule 110 is one dimension. Yes, I forgot it's one dimensional. So, yep. Printing state worked perfectly, right? Printing state worked perfectly. All right, so if I try to do something like this, all right, cool. So the two-dimensionalness of this entire thing comes from the fact that each individual row is the single state, right? I'm sorry, I'm getting really tired right now. So that's fine. So it may happen if print state, if this entire loop didn't actually advance properly. That's only a reason why it may happen. So let's actually try to get rid of the j. So j does not exist anymore. Can I just do it like this? Var I. I wonder what was the mistake there. So it's going to be I less than this thing, and then we advance the I, and that should work, hopefully. I don't know. And we found an error. Okay, we already found an error. Interesting. So, and if I try to like write some stuff in here, hello world. So it printed hello world once, but then this entire condition didn't like work out properly at all, which is rather interesting. What's funny is that I'm pretty sure if I comment out this thing, it works fine. So something within print state actually screws up the stack and whatnot. I think that's what it does. It screws up the stack. All right, so let me maybe make the example a little bit more reproducible. Can we make it more reproducible? That's the question. Right, so let's put it like this, and I'm gonna be just doing something like write hello world, right? Write hello world, and here we're gonna try to run foo bang. Right, so, and we have several hello worlds in here. Now, if I introduce another procedure, right, so here is another procedure. So everything is fine, but I'm gonna call these procedures in between those things, and something within the procedure fucks up the stack to the point where, well, something's definitely wrong. I wonder what exactly. So it's something about compiling the function calls. Or maybe not function calls, it just actually depends. So we precisely found an error, like here it is. So we have a pretty reproducible example. Yeah, so you comment out this part and it works. You do that, doesn't work. Does not work, does not work. Let's troubleshoot this entire thing. So we have three places, actually two places. Compilation of the procedure, something went wrong in the compilation of the procedure, and the compilation of the function call. I don't think there's anything particularly special in the compilation of the function call. You just jump into that procedure. All right. then inside of the procedure, the frame is prepared, and at the end of the procedure, the frame is disposed. Okay, don't see any problems with that. Okay, so I don't think there's something with the function call, it's something with the compilation of procedure. Compile proc definition. Okay, so here is existing procedure. We push the new frame. Push the new frame. If the frame exists, we take the offset from the frame. Then we allocate this stuff for the frame. The frame should actually be 0 initialized, so it should be totally fine. And then we compile pop the frame, and we just pop the frame. And then we simply return from this entire stuff. So compile push the frame, I don't see any problems with that. Compile pop the frame. Maybe the thing we need to try to do, we need to take a look, like, let's take a look at the assembly, I suppose. I think we need to take a look at the assembly when we try to call this entire function. It could be also so the offset is taken from the previous frame, but do we update the offset? Do we update the offset? We must be updating the offset. This one is complicated, actually. This one is complicated. So yeah, let's take a look at the assembly. So I'm gonna be just building this entire thing, right? So here is the build, and now I'm gonna go to debasm bin debasm foo bm. Shit. I forgot to set the stack to be small. So now the Emacs is dead yet again. Alright, let's try to recompile this entire stuff, but now this time let's set the stack to 64 or something. So, let's try to debasm it one more time. There we go. So what is going on in here? What is going on? There's not that many, not that much information, unfortunately. So here's the hello world, or something like that. All of that appended in the single foo. What does single foo do? So interestingly enough, if the variable located outside, right, if the variable located outside, and you try to run this entire thing, it is working. It's specifically when the variable is located inside of the scope, right? So maybe the allocation of the variable is not like happening properly. So that could be also the case. Let's see if we can catch that, hand that down. Let me see. The allocation of our nation. Compile stack variable. What if it's not deallocated properly? But I mean, I implemented the allocation properly, I think. So we take the type, we check that it's not a void. So we find if there is existing variable, right? Variable already exists. So then we take the type definition. We assign that, so we set the storage to that. We check that we have a frame, and we update the offset of the frame relative to the thing. And the address is essentially the new offset, right? The address is the new offset. And then I just add this entire variable to the scope. So when I do compile pop frame, well, frame is just like yeah, it takes the current frame and just reassigns like the previous one to the current one. So it's not that big of a deal. Pop the scope. You have a frame. It's a stack storage. You take the definition and you just deallocate it. Deallocate this entire offset thingy. So should work, in my opinion. But apparently it doesn't. Pop scope. So pop the scope in here, compile block into Basm. I really don't see any problems in here. I really don't see any problems. So what if we maybe can we try to print the value of this thing? I'm gonna just take a pointer to I, and so it has to be like very big, right? So let me see. I might as well actually print it as 8. Right. Oh well, I mean, I have to take the pointer, of course. Pointer to this variable, and this is what we've got. So that's the value we've got, and I wonder if I can just take the XDD of this thing. Might as well actually just straight up XXD, and it is actually a bunch of 0 and 9. That is very strange. And then at the end it's actually 10, but didn't manage to reach the... It's 9. Would you look at that? Its value is 9. Well, no. Is it? Well, it is 9 actually. Well, maybe not. Because it has to be just 10. Right, it just has to be 10. And in here, so it's a world. Why did it become... So this is, there's 9 characters in here. Because there's also, okay, 1, 2, 3, 4, 5, 6, 7. And here's the new line. So I is completely busted, like a really busted. Maybe we can basically try to have an example that looks like this, right? And with this specific example, we could try to trace what the hell is going on. Maybe we could even make like a smaller thingy. And then probably assign to 64. It feels like the compilation of the new frame is completely broken. The compilation of the new frame. Okay, so if I do something like 69 without the tracing, right? So I'm not doing any tracing. And if I try to print this entire thing, I'm going to try to do write. Write ptr, and I'm going to take the pointer to I and treat it as a single thing, maybe even as like 8 of let's actually do a single thing. Yet again, it has to be E, right? It just must be E, and it is in fact E. Now, what if I try to print it several times? It's EE. What about calling F first? It is busted after that. Okay, so can we make... Okay, so we actually made this example simpler. Okay, this is like way simpler example. Right, after the call, it is completely busted. Okay, that's nice, that's nice. I really like that. I really like that. So there is a simpler example, very simple now. So, and if we try to trace this entire thing, can we see some numbers in there? I think we should be able to. So we call the function. All right, so we push 32 we read the stack, then we push 0, push 8, -1, 20, and that stuff becomes 18. So right, so if you go into the current frame, all right, if you go to the current frame, it's going to be 18. You know what would be even cooler is that for each instruction we could have like a statement that is associated with it, so we could print it somehow. I don't know. All right, so then here's a 45. Right, here's 45. And then what we call in here, okay, I think this is, yeah, so call 0 is calling to f, right, we're calling to f. Okay, so here we start to actually push a new frame, right, we push a new frame, we're pushing -I or something, push 8, -I, duplicate some shit, reading, and we're finally writing. And you know what's funny? We had a value of 45, which is 69, right, of 45, which is 69 on the stack frame, and then it got overwritten suddenly with a pointer to the previous stack, right, with the pointer to the previous stack. And then, okay, so literally what happened, the variable got overwritten by that goddamn frame. So that means we didn't offset this entire thing enough. What the hell? Didn't I specifically like code that you also take the offset of the frame and just, didn't I code that? I don't quite remember. So let's take a look at this entire thing. Compile new frame, compile new frame, push new frame. All right, so we're reading the frame address, then I offset the frame address to find. So I do frame top offset, and I do minus this entire thing. I do minus this entire thing. And yeah, it should just work. So the only thing it may not work is if frame top offset is never actually set to what I think it's set. So let's go like this: frame top offset, frame top offset. So I can already see the bug. I can already see the bug, which is good, which is absolutely good. And let's just run this entire thing. Okay, nice. One of the frame top offsets must be bigger than 0 to accommodate the variable. Okay, this is straight up wrong. The second, okay, the first one is fine, but the second one, right, when you perform the call, it has to be, yeah, it has to be done accordingly, I think. Oh shit. You know what that means? That means it has to be communicated at runtime, I think. Ah, shit. Okay. Okay, I see. It has to be communicated through a runtime when you make a call. Right, when you make a call, you need to know where the top of the stack is located. So yeah, it's, I see, that makes sense. That makes sense. All right. So it is in fact a runtime value, but that will require like changing the entire thing. Actually, that will require changing the entire thing. So you have a stack frame, and at any particular point of time, we do know the size of the frame, the size of the previous frame. The question, okay, I think there is an easy fix. There is an easy fix. The goddamn frame has to be pushed and popped, not inside of the procedure. but outside of the call. Yeah. Okay. I think I see what's going on. Right. So we're pushing frame and popping frame inside of the procedure body. But the problem is that at this particular stage, we don't know the size of the previous frame to determine like where to offset. The idea is move these things to function call, because when we compile a function call, we know precisely the size of the frame in here, so we can, okay, that makes sense. All right. Cool. I'm really glad that I actually managed to find that. So this is definitely a problem. All right. That is very, very interesting. Okay, compile, push new frame. All right, so the procedure itself doesn't give a goddamn about the frames and shit. All right, it doesn't give a goddamn about frames. Because of that, think. I think because of that, storing the frame in each individual scope is kind of redundant. But I guess that's fine. I guess that's fine. Oh shit, and if we push in the... Alright, this one requires another cup of tea, so let's make a break and another cup of tea. Everything is simpler than I could have imagined. So, let me see. Okay, so variables could be located only in two places, right? It could be located at the top level of a module or as a statement. There's literally no other place where you can place a variable, right? So, and statements right now only exists inside of the procedure. So that means if you're compiling a local variable, you compile a variable as a statement. So that means you're always inside of a procedure. So that means there's no need to keep track of the frames and to which frame scope exists and whatnot and whatever. So you can just have a single global variable that keeps track of the current size of the frame. Right, of the current size of the frame while compiling everything, and you can use the size of that frame to prepare the new frame when you call a function and then dispose that frame. So it's that easy, apparently, I think. I do think so. So let's quickly implement that. That means we just need to get rid of the notion of the frame. Yeah, let me see, where is the frame? Bang frame. So just straight up remove this entire thing, whatever. The other thing I want to introduce in here is a global variable along with the scope, and it's going to be something like a frame size. It's going to be as simple as that. Initially it's going to be 0, but then as you allocate more things, you append things to the frame size. All right, so let me try to recompile the entire thing. Boom. Okay, so bank frame, so there's no frames in the scope, it doesn't matter. What else? When you compile in a block, you also don't need to specify this entire stuff, so it is gone. Another thing, pushing a new scope also doesn't matter, so that just doesn't matter. What else? What else do we have in here? So what I'm compiling in here, I'm compiling if statement, so that means I can just push. I can just compile the block without providing the frame, so all of that doesn't matter at all. Okay, what's going to be the next thing? So what we're compiling here, we're compiling the while loop, the same thing with the while loop. All right, absolutely the same thing. And here we're compiling the block. So as we compile the block, right, we don't need to do that. We don't need to do that. There we go. Compiler assisted refactoring. All right, so when we're compiling the procedure, we're pushing, yeah. We should not push any frames as we compile a new procedure. Just don't push any frames, right? No pusher for the frame. All right, anything else? Anything else we need to do in here? So when I'm compiling procedure, yeah, there's no need to allocate the frame, and also to do that, all of that is completely redundant. Just compile the block and just return from the block. Don't even worry about that. Don't even worry about that. Okay, so here is that. This thing does not exist. Okay, this one is very interesting. So it's gonna fail compilation in a place where I would expect. Okay, scope frame. You allocated a new variable on the frame. So that means you need to add the size to that variable to the frame size. There we go. So that's how we allocate in a variable. That's how we're allocating the variable, and the new address is going to be essentially the frame size, right? So it's going to be basically frame size. So push a new scope. This thing is not needed. This thing is not needed. Boom. So pop the scope. When you try to pop the scope, regardless of whether you have frame or not, you just iterate through all of the variables, and if you have any stack variables, you basically subtract their total size from the frame size. That's how we deallocate them. There we go. So it's not really scope, it's more of a bang. Yeah, it has to be a bang. Automatic memory management, how about that? This is almost array AI. Almost array AI. So the only thing we need for a proper array AI is on each of these variables to call their destructor. And that's how you're gonna get array AI. Easy, is it not? Pretty goddamn easy. So this is another one. Okay, cool. So everything's compiling. We got rid of the frame, we introduced the frame size, but now we need to implement the final idea, right, that I had. Essentially push the frame not inside of the function, but outside of the function call. So before calling a function, you prepare the frame, right, and then you call the function. Function uses the current frame, and then it returns from the body, and then you dispose the frame. So that's how I see that. And what's interesting is that the scope within the current function will automatically deallocate all of its variables, right? So if you allocate the variable, scope pop will also remove that variable, so there's nothing to worry about. Okay, so everything seems to be coming up together quite nicely. So call, I think it's a fun call. All right, so if we have a fun call, so this is the regular, okay, get compiled procedure by name, and then we just perform the call. And this is where we have to prepare the frames. All right, so let me find this stuff. Compile push new frame, right? Compile push new frame. And here's the interesting thing. The offset is basically this size of the frame. Because of that, I think there's no point in even providing this shit, right? So just remove the shit completely. Right, we're providing bank, we're providing Basm, there we go. So, and after that, we need to compile pop frame, right? So we're just popping the frame out. So pushing the frame, performing the call, return from the call, popping everything. Okay, that's precisely what we want to do in here. And let's go through the compilation errors. Okay, so this function, too few arguments. I think I need to update this function signature in the header file. Semicolon. Anything else? Anything else you want to say to me? Semicolon. Imagine requiring semicolons in 2021. My God. So this one is not needed. Okay, and in here we're going to be just taking the frame size from bang itself. There we go. Frame size. Okay, that's pretty cool. So let me take a look at what we got. Okay, so I'm not going to call this function, right? I'm not just not calling this function just to test the, like, you know, the regular situation. Bing, bang, run, foo, bang, and it printed E. It in fact printed E. Now the moment of truth. I'm calling the function. Will it still print E? Got clear. By the way, actual got cooler. Okay, so what if I yeah, this one is interesting. So let me try the following thing. We're gonna have var x. I might as well actually move var x inside of the scope. So x initially going to be equal to 34, 34, then x plus 35, and then in here we're going to be initializing I. Maybe it makes sense to actually get closer to the place you plan to use it, and then while I is less than 10, we're going to be taking the pointer to x and printing that x as a single character. So on top of that, I think I want to actually rename this function to line, and what this function will do, it will simply I don't know, print a bar of some sort, right? So it basically will separate each individual e, and here we're calling bar. There we go. So not a single global variable, everything is allocated on the stack. And let me see what's going on in here. And of course it doesn't compile because we forgot the semicolon. And well, that was my mistake. That was totally my mistake. It's not a mistake of the compiler. So I forgot to increment I. Okay, it printed E 10 times, hopefully. So it's 20 characters, yeah, and 10 words. It printed E 10 times, and there we go. We have local variables working properly. My God. All right, so apparently my initial understanding of how to implement a stack for local variables was completely wrong, right? Until I tried to actually use the local variables inside of that stack, right? But I mean, so fundamentally it was correct. So the frames, the structure, the data structure I used for the frames is correct. I didn't have to change anything in how you push the new frame and how you pop the new frame. Nothing here has changed. It's just like how you, at which point you do that, right? So my main mistake was that I thought I'm gonna push the frame in here and pop the frame at the end of the function, where in reality it is way easier to do that in here, because inside of the function during the compilation you simply don't have enough information about the size of the current frame. You only have the information in here, right? And this is going to be super important as we implement another very important feature that is related to the local variables. It's the arguments of the functions. Yeah, we right now do not support arguments of the functions because it's not implemented yet, because we didn't have a stack. But we do have a stack, and that means now we have a technical capability of implementing the parameters for the function, and that's going to be actually super cool. So, yep. All right, so the thing I wanted to do here is first commit everything I did. So rule 110 doesn't require to be changed or anything. So the main thing that we did in here, so I have something stashed in here. Oh yeah, so this one is not needed anymore, it's already stale. 455 push pop the frame on proc call instead of proc body. Yes, that's quite important. And let's push that right into the repo. So now, since we have everything working, maybe we can finally refactor our rule 110 to use local variables a little bit more. Let's actually go there. Bang example rule 110. Here it is. Let's enable the highlighting, and let me go to here and just do bing bang run example rule 110. Here's rule 110. Isn't that amazing? I think it's getting amazing. So again, the thing we're gonna do, we're gonna remove these variables in here, right? And go through the compilation errors. Var I64 cell PTR. Oh, we already had something. Really? We already had something in here? Huh. Oh yeah, okay, so that's fine. It's totally fine. So we already have that. We don't have cell PTR. Let's introduce something like this. Cell PTR, and cell is U8. Next one. So as well var I64. Anything else? Cell PTR. Might as well put it somewhere here. Var cell PTR cell U8. Anything else? J. And here we don't need to have J. We can just use I. And I can replace J with I. Boom. There we go. Works perfectly. Perfectly. My God. So yeah, we don't use global variables for you know, local intermediate stuff anymore, right? For this kind of stuff, we're using, you know, things on the stack. That is goddamn cool. My God, I'm super proud of it. I'm super proud of it. So okay, so it's going to be 455. Refactor rule 110 to use local variables more, right? And let's do the same thing for the game of life, right? So here's game of life. So here, in fact, we have a lot of things that must be local variables. This is actually a better example. So in my opinion, only this thing has to be global. This stuff, all of this stuff can be local. This one is way more interesting. Okay, so let's do a control test where I'm gonna just run game of life, and there you go. Here's the glider moving around, right? So it's basically frame by frame animation of the game of life. And I'm gonna go to the goal, and I'm gonna simply comment out all of these things and see what's gonna happen. All right, so let's go to the compilation stuff. So here's the row. Okay, var row I64. That makes sense. Another one, var call I64. We definitely need to implement initialization, so I can just do something like that. That will be way more convenient. And also for loops, of course. Like, yeah. Cell PTR. Do we use cell PTR anywhere outside of this stuff? I don't think so. Alright, so we only use cell PTR and cell inside of this entire loop, which means that I can do something like var cell PTR, which is a pointer, and var cell U8. And the cool thing here is that this stuff is not going to be even visible outside of this loop, right? So if you try to do something like, yeah, cannot assign non-existing variable cell, right? It's not visible outside of the while loop. Which is perfect. So here we have var row I64, and this is another one, var call I64. Cannot assign neighbors. All right, so we don't use neighbors anywhere, I think, outside of this thing, right? So where do we use neighbors? So it's there, and then we use it down there, right? Which means that I can simply do var neighbors I64, so it only exists in here. All right, so drow. Okay, this one is also very interesting, so maybe I can do something like var drow I64, and this is the similar thing while decall I64. Okay. Anything else that is needed in here? Cell PTR. Okay, cell PTR. I can see that cell PTR is needed only here. Var cell PTR cell U8, right? Anything else? Var I64. Cool. That's pretty cool. All right, and it works. Okay, so it worked first try. God Cooder moment. Am I right? Am I right, fellow God Cooders? All right. So, and that means maybe in goal I can finally go in here and just remove all of that stuff. Remove all of that stuff. We definitely need to implement initialization of the variables because that will make the code way more concise, right? And maybe we could get rid of the initialization step, because all of that could be initialized maybe at runtime, but for that we'll need arrays and stuff like that. We don't have arrays yet, so arrays is going to be completely like a different topic. It's going to be a very interesting topic. All right, so yeah, we'll go to the compilation and everything seems to be working. 455 a refactor goal example to use local variables more. Right, there we go. I'm gonna push that right into the repo. So, and let's create the so we have a pull request from oh, okay, so I'm gonna take a look at that after the stream. Thank you, Hudson Plots. Thank you. All right, so what was that? Taking the point at, okay, so we went on a huge tangent with this one because this was about taking a pointer to the variable, but to be fair, I expected after implementing this issue to, like, for this entire thing to work correctly, but it didn't work correctly, so everything was here to actually fix this entire stuff. So yeah, implement PTR for local vars and fix the semantics of the stack frames, and I'm gonna close this entire thing like so. I hope I didn't introduce any to-dos list unreported. Right, I think I didn't. Okay, so everything seems to be okay. Everything seems to be okay, and on that note, I think I'm gonna finish this session. Thanks everyone who's watching me right now. I really appreciate it. Have a good one, and I see you all next time, either here or on Twitch. Yeah, check out the description. I'll put all of the links in there. And I gotta go. Thanks everyone for watching. Love you all. Mwah.